Welcome to the Metal Building Show. My name is Eric Beavers, owner of Great Western Building Systems. Today we're going to be talking about foundations and anchor bolts. I want to go over all of the pretty much everything when it comes to foundations. I want to talk about footings, foundation designs, when a foundation isn't required, and then of course anchor bolt settings. I just thought this would be a good topic for us to jump into. Everybody has a bunch of experience with it, and yeah, so I'll let you guys introduce yourselves.
So I am Jared Miller, Chief Detailer here at Great Western Buildings.
Hi,
I'm
Jared.
Aaron Cowdy, the yard manager at Great Western Buildings.
And I'm Justin. I'm the media geek here producing.
Well, thanks for joining me, guys. I know that since I was traveling, Jared, you didn't think that I would be doing this, but like I did travel with my stuff. I wish I would have gotten it set up before. But since we're kind of behind the schedule here, let's just go ahead and jump in. Foundations, concrete, rebar, anchor bolts.
Fun
Right?
stuff.
Fun stuff. So a lot of usually takes us a few seconds to get going on this stuff. But actually, I do want to do we were talking about doing market updates, logging into CRU right now. CRU, yeah, these mills, man, I swear. Continue as Eric, see the full chart. Yeah, CRU, since I've been traveling, man, CRU climbed all the way back up to $912 a ton. It's come back down, but where we were last week, we're still up. Geez, where are we at here? I guess we're up about $25 a ton or so that'd be what? 2.5 cents up. No, well, not much, just about 2 cents a hundredweight, but it's all over the place, man. They keep driving it all the way to the roof and it keeps coming down. I don't think that there's the demand in the market to hold this, $1,000, $1,100 a ton target the mills keep placing. And it is a cabal where I think they get together, Cliffs, Nucor, Arcelor, US, they all get together and drive it. And then they just slowly start, coming back down. But the trend over the last 4 months has certainly been upwards. We're a lot higher than we've been in a while. I mean, to give you an example, at the beginning of the year here, steel had really come back down to reality in the mid sixes. 100-weight. And I mean, the tariff thing, whatever, that's the tariff thing, but there isn't a really good excuse for it, right? I mean, pre-engineered metal building companies, I think I'm not speaking for the whole industry. I know a lot of people buy Vietnamese steel, Taiwanese stuff, a lot of Mexican products on the market, but at least with Great Western, it's 100% domestic. And I think construction in general is about the same on that high quality steel. But yeah, no price relief.
That's unfortunate.
But I don't know when we're going to be looking at any additional increases or anything like that. We just, I struggle and fight and kick and scream to avoid price increases as much as I can. There's your steel market update.
There you go.
I think domestic capacity went up though. I think we're almost we're above 75% domestic capacity in production. So that's good to see the mills making a little bit more. They should be in the mid 80s, upper 80s. They like those margins. So, all right, Aaron, you've been in a bunch of job sites with bad anchor bolts. Should we talk about anchor bolts or should we talk about designs and stuff first? When is and Jared, you know a lot about this stuff too. When is a foundation design on a pre-engineered metal building necessary?
Man, I would almost say always, just about always. I can only think of like really one situation that kind of comes to top of mind where you wouldn't really need one. And that's basically if you were kind of doing like a footer design and you didn't have an interior slab, right? So it's like I've got like a great big combine that is going to have a dirt floor, but I still want a metal building over it. And that's about the only time that I could really think of.
Well, it's still not doing a footing design?
Yeah, you'd still need a footing design. I don't know if I would call it is that still a foundation design though? I mean, even if it's just footings?
Mm-hmm. Hey, footing's a foundation, right?
So yeah, I mean, every time, all the time.
I think you're right, Aaron. You've been around for a long time, and I think about 15, 20 years ago, foundation designs for pre-engineered metal buildings, even on some big ones, really wasn't necessary. I mean, a lot of the building authorities and stuff have picked it up. I mean, heck, we used to just do a 2-foot thickened edge slab, regardless of the size, 6x6 welded wire mesh. And, for the last, probably the last 50 years, until until about a decade ago. And those buildings are all standing. You know, my buddy Bobby Fitch, he put his building up on a 5-inch hot tub slab, man. And that's still there. Right.
Yeah.
It's like, what are you doing? It's only like a 24 or something.
That sounds brave.
Right.
But yeah, I mean, I've put buildings up in plenty of places where they didn't do a foundation design.
And
Montana
I think
being one of them.
A lot of times, I mean, a good erector or a good contractor can get away with it, right? They know what they're looking at. They know what they're doing. They've done it so many times, they can kind of just go for it. But the more and more the building authorities are requiring a foundation design, right? As part of the permitting process. But that's not a reason to decide not to do a metal building, right? If you go to the right, if you find the right vendor for a foundation design, if you have a good soils report or something like that, it is, really not expensive to get the foundation design.
Yeah. And with us,
It's under
not a
$1,000.
soils report.
No, a lot of building authorities require, if it's pre-engineered metal building, it doesn't matter the square footage.
Mm.
Yeah. And I'd say that's pretty much standard, but we have some ways around that, or ways to get foundation designs, through Great Western. And I think a lot of other metal building companies will offer, maybe not the big ones, not Nucor, not Varco, stuff like that. They won't do that, but some of the, I don't know, boutique metal building companies will do it. Yeah. A 40 by 60 foundation design. What, Aaron, I mean, you were in PM, what, 15 to $2,500?
Yeah.
Depending on conditions. And it's
depending on conditions.
Yep. And it's good because it gives you peace of mind too.
Yeah. It definitely helps to have that in your back pocket later on down the road. Like, hey, I had this thing, permitted and engineered and everything is good. What happened? Well, they set the anchor bolts only 4 inches in.
They used wedge anchors. Those are perfect.
They use wedge anchors. Yeah.
We made a whole video about not using wedge anchors.
Oh yeah. I do have the
pretty much half that video was just don't use wedge anchors.
What was that? Steel building disasters, right?
The disasters video. Yeah.
Yeah. It was kind of hard for me to decide to put that video out because it was 2 Great Western buildings that came down. I'm like, oh man, I don't know if I want people seeing this, but
you were just about it. That's what matters.
It was pretty important, right? Like, I mean, the one, there was Jared. Jared, did you ever see that?
Mm-hmm. Yeah.
Right.
It's not like we did anything to make them fall down.
No, but
clearly nothing that had anything to do with us. It just happened to have our brand name on it.
One customer in Colorado was like, man, the Erector says, your building is, not, well, both Erectors said the same thing, but looking at the pictures, I'm like, he didn't have it. He had all the frames up, Jared, and it was, flush girts. He had some girts on, no cables, no nothing, no purlins, but all the frames up. And it was a big, like a 4-foot haunch thunderstorm.
All the rafters and everything.
Yeah. Crazy.
Well, probably doesn't matter if you had regular J-hook anchor bolts tied into rebar. It probably still.
The anchor bolts didn't fail. It was an engineered foundation. The foundation was good.
Oh, okay.
They broke. They twisted over and broke, but they didn't pull out. And then the other one was were the columns, Jared, the center frames. Like he poured a perimeter wall, and then when the frame showed up, I guess he just built a 12-inch square box right next to the stem wall, and just poured concrete into it.
There you go.
The cold
There you go.
Yeah.
Yeah, I remember that picture.
There you go.
Right. Oh, hey, Dan. Oh, so DAW, I think it's LLL. Anyways, that his name is Dan. Him and I have been talking a little bit. He paid $1,200 for his engineered foundation for a frost protected shallow foundation in Colorado. That's cool to get an engineer to do that. Saves a bunch of money on rebar and concrete. I think that is a thickened edge slab is what they call a shallow foundation. We'll have to ask him to show us that design. But I think the biggest thing on getting a foundation though is finding an engineer, a professional engineer, a geotech company that. My audio is playing on the.
You got that
No, it's my phone. There we go.
You're watching the live stream on your phone, huh?
Yeah, I have it pulled up. I have it pulled up so I can watch the messages. Like I keep hearing something. So, anyways, back to what I was saying. Oh, local engineer, but it's important to find somebody that's familiar with pre-engineered metal building design. So a lot of engineers that, are doing standard, footings for homes and stuff, they see our plans and they're like, I don't even know how to read this. I mean, we're always willing to help, Dan, Richard, Raj, myself, we've all been on the phone trying to walk through calculations with engineers. Once they get their handle on it, then it's no problem. What I like about it though, Jared, is with a plan, with an actual foundation design, it gives you something to get bids on and to hold and to hold your concrete contractor to a standard, right? So there's no cutting corners and stuff like that.
Absolutely. Yeah, and I think that's the reason for going with pre-engineered anyway, right? Is that we're taking the time to look at the building design and will this hold up in a catastrophic event? And that's what we're designing for each load and every single area, of the country, right? Anybody can just go out into the field and put up some sticks and see, I didn't need anything, but will it hold up when the wind comes, right? That's always the test, right? And it's a system, right? We're tying into a foundation, right, with those anchor bolts and stuff. So we did our part, but if you were to, not have that foundation engineered, I mean, it's going to tear that part up. So the fact that they're both engineered together, right, helps once again, like Eric was just saying, with that peace of mind, because it's all good. I mean, it'll be there for over 100 years,
So what was I going to say? I lost it. I'm on vacation.
We noticed by your shirt.
Right.
Yeah,
you look my that's my brother-in-law behind me. He's over there working and
so you got a little something extra in your coffee this morning?
I got a coffee. I have I'm on vacation, man. I'm having a beer.
There you go.
It's just openly.
It's afternoon here. So I don't know if that's YouTube appropriate or not, but whatever. So what I was going to say about the foundation, we should go over some terms on foundations, right? When we talk about a thickened edge slab, all we're talking about is a monolithic pour. Monolithic just means all the concrete's poured at the same time. So footings, the slab and everything. A monolithic, you really are going to need to have a slab, especially with the thickened edge slab. And some people refer to a thickened edge just as a turn down slab. So basically you got a 4, 5, 6, whatever thick slab. And then around the perimeter, usually it's about 2 by 2, kind of a trench that you dig around the building, right? I like them because it eliminates a lot of the necessary work on formwork. So really all you have to do is you're really just forming above the ground, right? Just to hold the squareness of everything. That's the beauty of those things and super strong because all of your kick out and everything is tied in through the slab. So you don't have to have any grade beams or tie beams or, perimeter strip footings or something, but really it's generally for smaller buildings.
The question that we get, or at least one of the things that we've helped a lot of customers with, is measuring for their anchor bolts. That overwhelmingly, according to analytics, is what customers are looking for answers about.
Yeah, we did. We did that 3 video series on anchor bolts, but we didn't jump into anchor bolts. But so Jared, Aaron, then there's a strip footing design, and a strip footing is we refer to it as a 3-pour type system if there's going to be a slab. But a strip footing is basically where you have 1 foot, 2 foot, 3 foot, whatever it is. Perimeter strip, usually about 6 to 8, maybe 12 inches deep, depending on the building or thick, running the perimeter of the building. Yeah. That gets poured in place, and then there's rebar that's anchored in that comes up for the second pour, which does the stem wall. And we have a video of one of those going in at a customer's house out east. Oh man, I'm drawing a blank on his name right now, which is funny because I was just talking to him. But anyways, that's poured, and then after backfill and everything, then they come in and they can pour a slab, or you can just leave it with no slab. I think what we're seeing the most of right now though is spread footers on larger projects. And a spread footing is just a square footing, but just like a strip footing, except it doesn't run around the perimeter of the building. It's just underneath the columns. And then a caisson is tied in to that through a cage and a stem wall poured around the building. And we know why a stem wall around the perimeter is important.
Yeah.
A lot of times on these designs, people think, hey, this is why we don't use sonotubes, or just, sonotubes in the ground, right? One, there's drift, nothing's tied in, but really it's for frost heave, right? You want everything around the perimeter of the building going down to frost, right? Depending on the nature of the soil. And that's why it's real important if you're going to get a foundation design, and it usually will make it less expensive, not the design itself, but the work that has to be performed becomes a little bit less expensive if you have a geotechnical. If you don't have a soils report, the engineer kind of has to use like his worst possible case. So they're using 1,200, 1,500 bearing capacity. They're going to assume heaving soils. So it's always worth it. Maybe not like on a 30 by 40 or something, right? Because you're not going to save, a tremendous amount, but on a larger building, absolutely.
Well, we've had that happen with like equestrian centers where they don't want a stem wall around, and they've seen a guy just, pour sonotubes all the way around on a 200-foot building.
You've seen with nothing tying them in. I said you.
Yeah, with nothing tying them in. Yep. No, we've both seen it. I can't remember who that was, but
was it one of our buildings?
Yeah, and they had the calculations written down on a little notepad.
I do remember this. Oh, was it an equestrian? That was the same one.
It was equestrian. We had to figure out how to do the base.
Yeah, because without a stem wall running around the building, there was nothing to tie the base channel or base angle into.
Yeah.
So we had to send him. Base skirt.
Yeah.
Yep. And and his buddy did the engineering. I swear it was like some guy that he met at the tavern. He's like, hey,
it was literally like bar napkin.
It wasn't quite that bad, but it was just blank pieces of paper with a bunch of notes on it and sketches, like completely indecipherable.
It had a stamp on it.
Yeah, the guy was an engineer, but clearly, certainly not adequate. Maybe in like, if it was all bedrock or something. I think he was in Wisconsin. Yeah.
Yeah. He said, yeah. He wasn't worried about it. So,
nope.
No,
but so the reason why you want to tie everything in as well is for drift. You don't want one column, drifting or moving and the concrete not holding it into all the others, right? So it'll prevent that. But all in all, I think that the foundation designs are, pretty over-engineered.
I would say so.
Yeah.
It's a just-in-case scenario.
Yeah, and they have to justify everything through their calculations and stuff now. Like before, it used to just be a footing design, engineer stamp on it, done, no questions. Now they want all of the structural calcs, call out on the concrete being used, what kind of rebar, welded wire mesh, specs on that, calculations on that. It's kind of like a building system, but it's pretty easy and straightforward. So welded wire mesh or rebar? Aaron, do you have a preference?
I haven't done that much.
Well, I know you haven't done concrete, but as an erector.
Rebar.
Really?
Yeah.
I go welded wire mesh.
Yeah.
Just in case I have to drill an anchor bolt.
That's true. But are you going
to... In the cage and around the bolts, you always have to have rebar there anyways.
Yeah, I was going to say, you got to have rebar in there. You can't have whatever. Yeah.
So, okay, Justin, you were talking about, what was the question you were asking?
I think he was asking about the dimensioning of the anchor bolts.
Yeah, measurements.
Like projections? Oh, just layout.
Yeah, you could go all day with that.
Well,
one of the ones I see pretty often is the 2-inch notch or 1.5-inch notch for a sheeting notch. Someone measured out too far and got their stuff wrong.
Well, Jared, that's why we took that off of the plan. Right? Remember, we used to detail the sheeting notch into the layout, and it was causing confusion. So we're like, hey, you know what? We'll just take
mass confusion.
So steel line. Well, now, it's still given, confusion, right? People are like, well, I need a sheeting notch and it's not here. It is there in the plan, right? There's a detail for it and everything like that, but we removed the notch line from the layout, which I think was a good thing. It makes the drawings easier to read and it makes it less prone to mess up, right? When you're doing your measurements. If you're not, if the concrete contractor's not really paying that much attention, right? It'd be easy to miss the thing. And if you don't have a sheeting notch, it's really not the end of the world, right? The building system, kind of has a sheeting notch baked in with the trim.
Correct. Yeah. Ours does for sure. It's interesting, just different parts across the country and how they handle that too, right? Whereas like in Texas, sheeting notch is almost mandatory by most companies, right? Whereas, in Colorado, it's like, well, why would you have that? right? So it's just kind of every region has got their pros and cons to that. And once again, it's not a right or a wrong. It's just, what you prefer as a customer or building professional in general. But yeah,
I would say
sheeting notches can get too convoluted and if you mess it up, it's really hard to make it look good when you're sheeting. I prefer just to steel out to edge of concrete.
So you would prefer no sheeting notch as an erector?
Yeah.
That's funny. I would always prefer a sheeting notch. Now, hold on. What if you were guaranteed a good sheeting notch, clean straight
If
lines?
I was guaranteed a good sheeting notch and I wouldn't have to bust out a concrete blade and shave out 6 feet of,
6. Oh yeah, the wave.
Then yeah. If you got a good concrete crew that then most definitely a sheeting notch would be nice. But as it goes out there, it's usually a problem.
Right. The other benefit to a sheeting notch, so sheeting notch is not necessary, but it does widen the foundation by 3 inches in both dimensions of the building, assuming we're talking about a square building. So if it's a 40-foot by 60-foot building, out to out of the foundation would actually be 40-foot 3 inches, 60-foot 3 inches. So 1.5 inches on each side, and that covers the corrugation of the panel. But what engineers like about it, especially on a flush wall, right? Like on an end wall, especially like a heavy frame end wall, it puts an extra 1.5 inches of concrete on the outside of those bolts. And, on a high load, high stress building, it's the engineers prefer it. Gives you enough room to wrap a cage around and pushes those bolts in a little bit. So we're talking about breakout, right?
So it looks like we got a measuring to center of beams or center of bolts. It's a bit confusing. Typically what you do is you measure to center of beam and then measure out to center of bolt once you find, where your center beam is going to be. That's what it's meant to be. So you want to go from, the edge of concrete 4 inches to the center of the beam, and then
to the web
1.5 one way, 1.5 the other way from center.
And Dan is saying measuring to the center of the bolt is a bit confusing. I don't know a better way to do it, right? Like always to the center of the bolt. If you're measuring to the edge of the bolt, that's going to start putting in some real weird math, right? Like a 5/8 inch or a 3/4 inch anchor bolt, because for the most part, all of our dimensions on a standard building are going to be like in whole inch measurements or half inch measurements, like 1.5 inches, but it's really 3 inches, right? In the gauge of the detail itself or the anchor bolt pattern for that. And yeah, so Dan, if you're measuring to the center of, if you're measuring to a layout, you put your tape, as long as you have a square slab, put your tape on the steel line, drag it over, and the plans show you that dimension, and that is to the center of the beam. Draw your line, put down your template, and mark out your holes. And you don't even, really, you can just do it with a speed square.
Yeah.
Right. If you got a good flat, heck, it doesn't even have to be that flat, right? There's Jared. What is it? Is it an 1/8 or 3/16?
3/16.
3/16.
3/16.
So
that's is our standard oversize. So we give you a little bit of play, but anything over that, the engineers start to get a little scared,
Oh, like 3/16 play in the bolt hole.
Correct. Yeah.
Yes.
Base plate to sit down. Yeah.
Yeah. So what, a 3/4 inch anchor bolt
is helpful.
Is going to get a 15/16 punch in the base plate. Yeah.
Yep.
Right. In a perfect world, it would be a 16th oversized hole, just like everything else. But trying to drop a beam down on that, you're going to tear up all your threads and have no movement.
3/16 help gives you a lot.
Quarter would be better. I don't know if that would pass.
What happens when you got to torch it out? I've had to do it too many times to count. Yeah,
but usually there though, you're not oversizing the hole, right? So you're slotting.
No, you're just usually slotting.
Yeah. So while we're on that topic, okay, anchor bolt grade, right? So what Great Western does call out on the plans, or any metal building company on their metal building plans, they're going to call out the grade, the diameter, and the projection of the bolt. And by projection, that's just how far above the finished concrete, the bolt needs to stick up. But they're not going to call out depth, right? That is up to the foundation engineer to decide the anchoring method, whether it's a J hook or a J bolt, or it's really the thing that's gotten really, really popular is just the nut with the washer on it.
Yeah. Yeah, I haven't really dealt with that too much, but I have seen that becoming more popular.
We've made them up in the shop for a couple of local customers. Oh, and hey, pro tip: do not, if you're going to buy your own anchor bolts, if you have a foundation crew that's coming out, they should be able to source the anchor bolts without any problem. But if you're going to go out and buy them yourself, do not go buy 3/4 and 5/8 inch all thread or 1 inch all thread from the home center. Oh my gosh. Right. I mean, that's like maybe if you have to drill one and epoxy it, but Fastenal or a steel supply center, like a service center, if you had something like that, I mean, it's better than half off. Right. And you just have to cut them into length yourself, but you can buy them in 10 footers. I think you can buy 1 inch and 20 footers from Fastenal. That might be a special order. I think 10 foot might be, or at least the one down the street from us is 10 foot. But I mean, basically what you would buy a 3-foot stick for at Home Depot, you're going to get like 2 10-footers.
Yeah, definitely.
Yeah. Yep. And I was going to talk about, grade. Anchor bolts. Jared, we designed 2 A36, right?
Yes.
Yeah.
Yes.
So any Great Western building system, unless there's been a special call out, I think on some spec jobs, we have used heavier or higher grade anchor bolts. But so we're just talking about mild steel, A36, or A307 would, I think, technically be the right term, a machine bolt, right? So
yeah,
it's not for the grade 8
or an F15.
Yeah, and they're all the same. It's just different. Well, A307 is a bolt grade. A36 is a steel grade. It's just a 36 KSI and tensile. So it's not unusual material or weird material. And it doesn't matter. It can be black bolts or black steel, or it can be galvanized. If you're doing all thread, it's easier to find the galvanized.
One thing I'd like to talk about, I guess, is door jambs, overhead doors, setting it. Do you like to set your anchor bolts before or after and use wedge anchors?
Well, it depends on what the design is, right? So a lot of times it's going to be
Right.
an end wall column.
Yep.
Typically. So that should be poured in place, would be preferable. But I would never use a wedge anchor, even for a regular garage door. I wouldn't use a wedge anchor. I would, even if as the erector, if you're setting them, I think it's a little bit more work, but it's a lot more peace of mind to drill an epoxy.
Well, yeah, or drill an epoxy, whatever. I guess the issue I've always had is, setting up your whole entire building when you have your overhead doors in and you already have bolts there to exact measurements.
Right. And then you have to
plumb that building up, and then, the doors sitting like that because you have the anchor bolts already in, you wet set them instead of coming in after the fact.
I think on end walls, I'd prefer them to be wet set. On side walls, I would probably prefer to drill.
Yeah, I would definitely prefer to drill.
But except for personnel doors, never have those preset. We don't even show them at the location.
Yeah, we don't even show those
on the drawings, and that's okay for a wedge anchor, like a 5. Like I like those 8-inch long ones.
Yeah.
Yep. Okay, so hey, your metal building company is not going to provide any of the stuff that's set in the foundation, right? So if it's rebar that's in the foundation, we're not providing it. If it's obviously anchor bolts, great, metal building company's not going to provide it, right? And 2 reasons on that. One, when your building shows up, you should have your foundation done, right? So if we're going to be supplying anchor bolts, which we have done before, just upon special request, but we're not going to want to ship them by themselves. It's going to cost more to ship those bolts than they're worth, right? So the only way that would make any sense to ship them, if the customer did tell us the depth and everything that they needed, the only way it'd make sense would be to ship it with the building, which kind of defeats the purpose, right? And hammer sets.
Yep.
Yeah. So for base angle and base channel and stuff, that those anchors are not going to be provided as part of the metal building system. I've considered it, but I was talking with Dan or Richard, I think, and it's not really an engineered aspect. So we kind of want to leave that up to the customer. Right, whether they're using 2-inch hammer sets or if they're using power loads. Have you ever used power loads to put down your anchor bolts? I mean, your that ever work?
Yeah,
I tried it. And
we did get away from it. I'd have to ask, my uncle or grandfather. But when I first started, that's what we did. But we definitely got away from it and started using the hip pins.
Right.
And I think mostly because it was you get a lot of blowout from concrete.
Right.
And that
or the nail not getting all the way through because you're going through the steel, which is
Yep.
easier than going through the concrete. But when I've tried it a few times, and it seems like the nail is only getting like a quarter of an inch in there and is bending and not working. I mean, it's much cleaner, much better to, in my opinion, to pre-drill the holes in your base angle or base channel and then use that as a template to drill the concrete. Just nail down a 2.5 inch hammer set redhead.
Yeah, and it's not hard. It's pretty simple. So
right, that's satisfying too.
Yeah, it's fun.
Dan says sheeting notches rule. I agree, Dan.
Hey.
If they do. Okay.
I would agree, but put up 100 buildings and come back.
Right. It might feel different.
Once again, it would definitely come back to, has a foundation crew done this before? If this is their first one, you may want to avoid that,
Right.
Right. Or participate with them. And I tell customers all the time, like, hey, if you want us to speak to your foundation or, your concrete contractor and explain this, just have them call, right? I mean, Dom, Tony, myself, Aaron, you, I mean, there's a handful of people always available on the phone to assist. Right. And a lot of times people have a hard time with the hold line too. They're like, hey, that's the critical measurement, right? The hold line between the frames.
Yeah.
And that gets missed. Like, it's the first thing when I was erecting, it would be the first thing I'd do when I showed up to a job site. Before I'd even check the length of the pad or anything, I'd check that hold line just to make sure. And then
lasering too, checking how level everything is. That's a big one.
What are your guys' thoughts on leveling nuts?
I don't know. I mean, I don't want to get onto a building and have to use leveling nuts unless it was some type of standard for the building,
Why? Well, I mean, it's certainly easier to just set the column down, right? If everything's flat, but I think on large, the concrete guys, they have their work cut out for them. I mean, I would say it's harder to, pour a foundation, make sure everything's flat, especially on like a large building, making sure that everything is, perfectly flat. I mean, it's doable. Certainly there's tools for it, string lines and chocolate, and all of that stuff. But
yeah,
I've had to use leveling nuts a few times, just where normally what will happen is where they will put the bolts kind of dangling in. Concrete crew will come in, pour concrete around it. They won't get a stinger up underneath. So you have a big void.
Yeah.
Yep. And I mean, I guess you could just come in non-shrink grout, but when you're erector,
I mean, I'd rather use a leveling nut than, an inch of shims.
Yeah.
Most definitely.
I got a question. So first of all, today we're getting a lot more attention than our other videos. So you have to excuse me if I'm being a little quiet. I'm just kind of paying attention to different channels that are, kind of talking about us. Something you brought up earlier, Aaron, and something you just brought up again, Eric. Sourcing your cement guy is important. We should probably maybe just kind of talk about that for a second, because it seems to be a serious headache for customers. Is there's cement guys when things go wrong?
Well, I think sourcing any of your contractors.
Yeah, this is a serious issue that needs to be addressed. So, well, any suggestions for the DIYer out there who's going to have issues
from they didn't get it right for a slab they did?
So concrete guy messes up, and that becomes a problem because then they're troubleshooting and stuff like that. Well, I can tell you the concrete guy's position on it. Aaron, you know where I'm going. That is definitely the metal building company's fault.
Yep, definitely the metal building
every time,
always,
every time.
So I think metal building erectors, they travel a lot more than concrete contractors, right? Concrete contractors generally are working within a much smaller radius. Or the thing about Mountain States, those guys will travel, I mean, regularly, within one state of Colorado. That's just standard for them. On the right job, they'll travel halfway across the country, or all the way out to Maryland for that giant building that they did. Concrete guys usually won't do that, but if you are going with a local erector, I would ask the local erector.
Yeah, that would be smart.
Right.
Yeah.
Because they're going to be familiar with their work, and they're going to be familiar with concrete companies or crews that are familiar with pre-engineered metal buildings. Right. Because you think about it, like a lot of concrete crews are doing not pole barns, but like timber frame stuff, houses, and they're used to wiggly wobbly lines because there's going to be a seal plate put down on it and it's all being framed out of lumber. So it's easy to square those up. With a metal building, you get one shot at it. So I would definitely ask the local erector. In certain places, we do have recommendations, the Front Range of Colorado in particular. But for the most part, we try to limit our exposure to recommending contractors because except for in unique situations, or I shouldn't say except for in metal building erectors always seem to let you down eventually. Right. And I would say concrete guys are the same, so a company like Great Western or any other metal building company, if they're making those recommendations, I mean, they're really lending their reputation to that contractor. Right. Because if that contractor, screws the pooch, it looks really bad on the person that, on whoever referred them. So we try to be real careful with that, but definitely ask your local erector. And if you're just going through the yellow pages or or I guess Google Maps, I would ask them, what pre-engineered metal buildings that they've done, and possibly even ask to see something because it is local, right? Just make sure that they're familiar with it, right? And I did for a couple of customers. What do you call a dire, or I don't know, it's like a legal term, but basically an and we've done that for customers before where we've jumped on the phone with their potential contractor and asked them some high level questions to make sure that they're, at least they know the terminology and the language. But
that's super helpful.
Hopefully that answered the question. And also the Discord, right? I haven't been on the Discord all week, but it's not getting almost any attention.
No, it is growing strangely.
Right.
Even though people aren't chatting as much as I thought, they're definitely there.
We will respond on Discord for questions and stuff like that. And hopefully some other erectors and stuff or concrete guys, will jump on there too. So I know it's kind of a new thing. You're not jumping into a already developed community or something, but customers, please jump in, ask questions. That way we can start building out the knowledge base. Anything else we want to talk about on foundations? I was thinking the cart before the horse thing. Jared, you want to jump in on that one?
Cart before the horse. What do you mean?
You got to have a building design before you can have a foundation design.
Yeah.
Yep. You sure do.
Yep.
Every time. It's the way that it goes, right?
But why?
You're definitely going to need to know how big the building is, right? Even just looking at your property, right? That you're putting it on too. A lot of, municipalities and stuff, they have easements. You can't encroach into this. Well, I've got 100 square feet of land. I can put 100 square feet of building. No, you can't. You've got easements that you need to consider, right? There's some of those things.
Planning. I'm talking about the, okay, so that you can put a 50 by 100, building. Why are we,
once we figure out, cool, here's your size, right? And we start going through our design process, right? We're going to work with you. How big is the building? But that's going to create reactions. Once you have, a certain size building, right, a 10 by 10 is going to generate one set of reactions lower. And as 100 by 100, it's going to generate different reactions, which is going to be higher. And that has to be transit. Once we've done that, we've established that building design, then we transfer that or, give it to you or contractor or whoever, that will be transferred into your foundation design. So it's one of those things that most people don't. We haven't exactly been entirely clear as an industry that this building is designed for you, for your purpose, right? We're not engineering this to, house 747s, right? This is going to be your barn door. You're going to put your little tractor in there. You don't need a 747, loading scenario. So we don't give that to you. By doing that, we're able to, keep the costs lower, right? Great general rule of thumb is, the more and heavier the steel, the more expensive it's going to be. Well, we're trying to lighten that up for you and your special condition, right? So that you're not paying for something that you don't need, right? But it is one of those things. Same thing is going with that foundation, right? Just because it's steel and it's concrete and it was expensive. Well, of course I can drive semi trucks on it while we're pouring this.
Well, I was thinking it's more like, the foundation has to be engineered to support the building, right? So really we need building plans in order to figure out what the foundation has to be support rather than building a building system around a foundation design. Which I suppose could be done, but yikes. That would be one of those deals that we'd probably say, yeah, no, thank you. So that's the kind of the big one. Aaron, should we go over the technique just in case you have to drill an epoxy for a bolt?
Yeah, we can. I mean, it's pretty. We have a video of it up in Floresta.
Did go over that a little bit. Customers always like it when you give them multiple opportunities to learn the same thing. So yeah, definitely talk about it today, but we also haven't in the past.
I was just going to say that you're looking at one of two different products. I would not recommend going to Home Depot and picking up the Silka product. It's not going to spec out the correct way. So you're looking at the Hilti HY 100 or 200 or the Simpson Strong Set 3G. The hole preparation is, I think, the most important part on that. I mean, almost even more than the epoxy, right?
Yeah. Depending on what we're talking about, if we're doing doors, yeah, you definitely want to make sure your measurements are right, make sure everything's laid out correctly, and then double check, and then maybe even triple check.
Right, double check, and then check again. Right,
you only get one shot at it.
So I was going to say, just like after you pre-drill a hole, or after you drill a hole for a epoxy anchor bolt, you make sure that you get the correct size wire brush and compressed air. You got to get all the debris out of that hole. Otherwise your epoxy is not going to adhere correctly to the
super
to the wall.
Make sure you get that thing cleaned out.
Got to be super, super clean. And depth on epoxy. I mean, that epoxy is so strong. I mean, it's almost stronger than, a regular port in place anchor bolt. The way it attaches to the wall. I mean, I suppose there's, some other factors and stuff in there, but usually, I mean, on a 3/4 inch bolt, every time I've seen it with the Simpson Strong Set, you're only going down 8 inches, right? Yeah. I mean, that pretty much covers everything on a 3/4 inch bolt. Always go a little bit deeper if you want, but yeah, hole preparation.
And another thing you want to look at is, what the temperature is that day. How long is it going to take for that to cure before you can actually put the column on it?
Right.
And the product will tell you, certain temperature will take this long before it cures it. So that's kind of important, middle of winter or middle of summer, just depends.
Yeah, that is important. Okay. I think, are we good?
I think so.
Anything else we want to talk about on foundations?
I just sent, getting messages actually internally. It looks like our salespeople and our PMs, other people have started watching our channel. Whoa, kind of talking hard of getting private messages like, whoa, okay. People are inside our company are DMing me. So kind of didn't expect that today. So I apologize if I've been a little quiet. Getting a lot of response. So good. Yeah.
All right. Was there a question or is that it?
A couple people have just kind of reached out and asked for the Discord information, and I sent it back out.
All right.
Yeah, it looks like people are watching a lot more than I thought.
Okay. What are we going to do? What are we going to discuss next week? We kind of wung, just wung it the last 2 weeks.
Yeah. Components.
Let's see what some of our watchers and stuff want to hear about. Hit us up in the comment section or on Discord.
Okay, hold on. I do have a question. This is actually from one of our salespeople.
Yeah, I just got them.
At what point will we offer the engineered foundation drawings? So I'm not sure what Josiah's asking. I think so. I think what he's referring to is on the sales side. Generally speaking, we do not offer foundation designs any longer on the front end, and that's not because it's a profit center for us or anything. I mean, all of our foundation designs are subbed out generally through MVE in Utah. Great company. Really, really good group of engineers. They're a little bit slow right now, or backed up right now, I should say, but really good work. But what we're running into is just the communication between the customer and meeting those expectations, right? So really we're saving that, offering that if it's needed, really post sale, right? They're not expensive. I mean, complicated buildings, those foundation designs can get kind of expensive, $3,500, $4,500, $5,000, depending on them. I don't think I've ever seen a foundation design go through us that was more than $5,000. But generally, I would say, if you wanted to just put a number on it that's safe. If it's a standard building, $2,000 is going to get you there. So it's not about trying to conceal price or cost or anything like that. It's really just making sure that the customer is requesting the correct foundation for their area, right? And also seeing if we can't get a geotechnical report, the soil conditions, because that's going to dictate exactly what that foundation has to be. And the geotechnical engineer that comes out and does the soils test and does the report will usually make recommendations to the professional structural engineer that's doing the foundation design itself. And they'll list a few options. So it's really important to get that information and make sure that we're providing the customer the best solution. Because if it's just, hey, cool, foundation design included $1,500, no problem. But you might get a thickened edge slab with a small turn down that's completely unsuitable for your soil condition. And when I say that like a monolithic pour, if you have really good soil and a decent operator with a backhoe, you can use the ground as the forms. That's great if you got the right soil, right? But like here in Colorado, especially in the mountains, once you dig down a few feet, you're getting into rock. And those holes are just, you're pulling out giant rocks and you're just making the hole too big to economically fill it back up with concrete. So really you want to over excavate there and then form to save the concrete. It's more work, but it's going to be less money. So that's why, to answer his question, that's about the.
Looks like Jay here has a question. He says, practically speaking, why is wet set better than epoxy? I guess that's another common question our customers are asking.
Because epoxy,
I'd rather wet set than drill.
Right. It's a miss. A lot of people think, oh man, it's going to be so much easier. And I mean, fundamentally it is. If you have a perfect foundation, perfect flat slab, and you have a nice smooth surface, and then you as the erector or the customer gets to go out with a tape measure and mark everything, verify it, pre-assemble some stuff before you even drill, then set your anchor bolts. I think there's two drawbacks on that. One, that is a lot more work, right? Especially once you start drilling, depending on the foundation, you're guaranteed to hit rebar. And that's literally miserable. It's the worst experience that you can have trying to set anchor bolts. The drill bits are expensive. They do have drill bits, concrete drill bits that will also go through rebar, but you're weakening your foundation when you're cutting through rebar down there, right? That rebar is not supposed to have a break in it. So the drill bit's expensive. It's hard work. Right. It's a lot easier to grab a 2x6 or a 2x8, lay out your form, put your bolts in and wet set them. Right. So long as you go back and forth and check and make sure that they're right before the pour, which is basically the same thing that you're doing, laying it out on the slab. The other thing that people do not realize when they decide to use epoxy is the cost of those epoxy systems. Right. So it's a lot more labor. I mean, holy cow. I mean, Simpson Strong Set 3G, that shit's like $60 a tube. And I mean, and on a big building, you might be going through a couple of cases. So, I mean, it really adds a lot of expense and a lot of work. So really wet set is better.
Sounds like the channels are starting to get quiet. I'm not seeing any more questions.
We are at an hour. Hey, thanks for joining in, guys. We'll let you know what we're going to discuss next week. Thank you, Justin. I'm Eric Beavers. We'll see you guys next time. Thanks for hanging out.
See you guys.
Take care, everyone.